Recording in progress. Okay, students, good evening. So next we will start with the students who are in the online. Am I audible? Can you please confirm it? Okay. So now we are going to enter into the another topic. The next out of the topic of this Python, we are talking about NumPy. We are talking about the NumPy module we will discuss. So let me increase the font. Okay. NumPy module we will discuss. So let us discuss what exactly NumPy module is. So coming to the point of it, what is this NumPy module is? What are the uses of NumPy module? And we are going to discuss many more things as a part of this. So let us understand the discussion about what is NumPy. Fine. So first of all, carefully try to understand. Actually, this is also very, very easy. So by seeing lot of coding standards as a part of Python, and this is not a big deal for you, and you can easily understand and more interesting also. Okay. So like how data types we use it, like that we can use in a simple manner. Okay. So NumPy stands for numerical Python. Numerical Python. Right? This is a just abbreviated form of NumPy. Why we use this NumPy and what exactly this meaning is? Actually, this NumPy module is not a predefined module of Python language. So NumPy module, I'm giving some description here, original documentation, I will show you that. NumPy is not predefined library of or not predefined module of Python language. Right? But it is one of the third party module. It is one of the third party module. I'm just saying that third party module. So already in the class, once it is a third party module, what we used to do, CX_Oracle is not a predefined module of Oracle. MySQL -connector is not a module of Python, which is called what? Third party module. How we used to take in our Python programming? By using pip. See that they are answering it. By using pip tool. We need to install explicitly by using what? Pip tool. So moreover, NumPy stands for this numerical Python. The name itself says what is the meaning of it. I will come to that. And NumPy is not a predefined library or module of Python, so that it is one of the third party module. With this understanding, one can understand that, so that NumPy module must be installed explicitly by using which tool? Pip tool we can use it. Already we have a much experience about the pip tool in our class. So what should I do now? Install, I must say what? Install NumPy module. Install NumPy module by using which tool? Pip tool. How do you go for it? Pip, what is the syntax? Pip install, I need to say module name. Already I told you this type of syntax for you. And the syntax is what? Pip install the module name. So how do you install it? Come on, tell me now. How do you install it now? Pip install. What is this? That is called NumPy. I should say NumPy. So that it will be installed from Git or GitHub kind of places. So I'll go to my command prompt and I will install it. So let us go to that and try to install it wherever you like it. So pip install. What is this now? NumPy. Install NumPy. So that it is going to be installing now. So this requirement already satisfied in my system. Since it was already there, pip list I can say. So once you say list, it is going to show you what are the modules which is already installed. How you can uninstall it? Pip uninstall. What I can say? NumPy I can say. When you uninstall, it is going to be uninstalled. So uninstall, sorry. It is called uninstall. So once you say skipping NumPy, so NumPy, so this is going to be finding, existing, installing, uninstalling NumPy. So removed. Now yes, I will say, it is successfully uninstalled. So what I can do? Say this now. People list. So in this place, what is not there? What is not there? NumPy module is not there. Now I need to install or not? How do you install now? Come on, see. PIP, spelling mistake, you take care, ma. Install. What is this? NumPy. Say that it will be installed. So it is going to show you collecting NumPy, installing collected packages, some type of thing, successfully installed NumPy. What is the version? 1.22 point what? 3. So I can say pip list UC, it is installed here. NumPy, which is available. Are you able to understand this? Fine. So with this, we installed the NumPy. Which installed the NumPy? No problem, Renko. No problem. Depends on your Git and GitHub. You can install it. Let us go to the place and Python. Go to the place of this Python 3.10. Command prompt you go. Command prompt you go. There I can say. Let me increase little bit some font here. There you can say import NumPy. You can say it is available with us. And you know, import, you can also import as what? NumPy as some alias name or not? As K. So NumPy can be referred as what? K. So generally, people will be taken as shortcut as NP. Stands for what? NumPy. Something like that. So NumPy, yes, what? NP. So here and after, I will call it as what? NP. So here, print of NP dot hyphen version, I will write it. NP hyphen version, I will write it. I hope underscore version. Underscore version. I hope underscore, I think so. So that is called what? 1.22.3. 1.22.3. So how do you find the version of the NumPy? NumPy dot underscore version underscore. You can also do the same kind of thing with the Jupyter notebook also. With the same Jupyter notebook also. With me, there is a Jupyter notebook. Click on this Jupyter notebook. Click on this Jupyter notebook. So here it will be showing. In the browser, it will be opening that. It is opening automatically. So try to see this. There is new. In this screen, there is a new. Go to this Python 3. It will be opening the Python Jupyter notebook. So here I will say, first one is what? Import, what I can say? NumPy as NP. Here and after, we will say NP. Once that star is there, under execution, one is coming means it is successfully executed. So in Jupyter notebook, you need not to use a separate installation. Automatically, it is installed. Even if it is not there, you can say the same statement. Pip install your module name. Now, how do you print it? Print of statement, you can use it. NP dot underscore what? Version underscore version, you can say it is going to print 1.20.3. This is called a version of our Python. How to find out? Well, sir. Now let us go to either you can, if you want, I can show in this Jupyter notebook, or if you want in this place, anywhere else we can continue it. Come on, students. Next, I will continue here. We will install it. Then, what is the little historical development of this NumPy? Of course, historical development means I don't want to say much about that. A small word I will say. This NumPy module, final documentation I will give you, student. I will show you that. This NumPy module developed by Travis Oliphant. Right? So this is developed by Travis Oliphant, who is the father of this NumPy. And this Python is developed by Sir Rossum. And the NumPy is not a part of Python library. Keep in mind that it is developed by somebody else. And before this NumPy, before this NumPy, there was a library. There was an old library called what you know, numeric library. What is that library called? Numeric library, which is used to deal with the mathematical calculations. And the Travis Oliphant read this numerical library as a basis for development of NumPy. And he developed which type of module? NumPy module is developed. Like a Python programming to develop it. Predecessor of Python programming is what? ABC language. Like that, NumPy is developed by studying the library called what? Numeric library. This numeric library developed by Jim Hungunian. So he is a person developed this library. Before NumPy, there was a module name called what? Numeric library, which is developed by this type of person. He developed it, and that is read by the Travis Oliphant and rectified and added a lot of content and released to the industry called what? NumPy. Did you understand? So numeric library is coming from where? Olden days, and that is reverse engineered by or revised by Travis Oliphant with the help of other kind of people, and they released to the industry on the name of what? NumPy. This NumPy module developed in C programming and Python programming. This NumPy module developed in which language? C language. 80% of the NumPy module developed in C language. For the purpose of what? Fastest execution. And then 20% of the subject of NumPy developed in Python for comfortability in programming purpose. And overall together, we can use in where? Python programming and data science programming. Basically, you will use it in machine learning, in deep learning kind of places. We can use this NumPy kind of model wherever it is required. Understanding? And what is the most powerful purpose of this NumPy? The most powerful purpose of this NumPy is complex mathematical calculations. Complex mathematical calculations can be solved easily by using what module? NumPy module. Suppose, for example, I want to do addition of two matrices. How do you do it in Python? Definitely you cannot do in Python language within 2 lines of code or 1 line of code. Definitely you have to go for what? NumPy with 1 or 2 lines you can do it. We can do it in Python by we have to write our own logic for it. So that is a complex for writing our own logic. So to avoid such a complex logics, what is going to be happening? NumPy will provide it. For example, I want to calculate standard deviation, statistical programming, you take it. Standard deviation, mean, mode. Next is called what? Variance. I want to do such type of calculations. To go for such calculations, we go for what? NumPy module. And a NumPy module is actually designed for the purpose of organizing the arrays of elements. Which elements purpose they design? Arrays. So Python directly not providing arrays concept. There is no concept of arrays directly in Python language. Then how I can organize arrays elements? By using which type of module? NumPy module. So NumPy module is used for 2 purposes more effectively. One is for what? Organizing the elements like arrays, and one more is called complex mathematical calculations purpose. NumPy module we use it. And what is there inside of the NumPy? What are the benefits of NumPy? I want to show you some small technical differences. So let me take a small example. Let us go to the Jupyter notebook and try to understand. What do you mean by matrix? Can anybody can answer it? Slowly, this entire class I'm going to on giving the importance of it, and slowly I will get it into the part of the programming. So tell me, what do you mean by matrix, or what do you mean by array first? Array. C language arrays, C++ arrays, Java arrays, we have a separate topic. In Python, we don't have any type of arrays. That arrays can be intentionally or programmatically we can write in the form of list. Just look at that. L1 is equal to And don't try to think that it is going to be difficult. It is a dead easy. So first of all, you see 10 comma 20 comma 30 comma 40. This is called what? One type of list. Print of what? L1. Print of L1. So it is going to give you the output is something like this. It is called what type of elements? Homogeneous elements. But a list can organize what type of elements? Same type of elements. Different type of elements also can be organized. 10 comma Raj 34.56 and next is called true. Something like this. I can print this data. I can print this data as L2. I can print this data as L2. So I'm getting this. I mean to say list either L1 or L2 or whatever it is. It is organizing the data in the form of what? Same type as well as a different type of elements are organizing. But our concept today is what? Want to organize the elements something like a arrays. If you don't have a knowledge about arrays, arrays is nothing but what? Organization of homogeneous elements. Is called what? Arrays. Are you following what I'm talking? Say something head like that. If you go on seeing me, I am only fearing first. Arrays means what? Organizing of homogeneous elements. Is called what? Arrays. C language, if you take it, we used to take one-dimensional array, two-dimensional array, three-dimensional array. I'm going to show all these things in the class, provided if you grasp my concept. Array, English meaning of array is homogeneous organization of elements. Homogeneous means what? Similar. Now you come to that. Intentionally, you come to list. Is the list can organize homogeneous elements? Yes, definitely. In the properties of list, we already discussed. List is organizing the elements in the form of what? Homogeneous. Plus, it can also organize the elements in heterogeneous. But can we say that it is a purely homogeneous? We can't say, because it is going to organize which elements? Heterogeneous elements also can organize. That means I cannot take them as a pure arrays. Then who is the which concept in Python organizes the elements like arrays? First of all, are you understanding what is an array? What is an array? Array is one type of data structure, first of all. It is called one type of construct. It is called one type of object which organizes the data in the form of homogeneous. Homogeneous means similar. On that arrays, what we can do? Like matrix operations, we will do it. So in Python, there is no concept available for us to organize the elements something like an arrays. Python arrays are nothing but NumPy. First point, why NumPy is used? For organizing the elements in the form of arrays. First thing. Second one, NumPy is used for dealing with the complex mathematical calculations. For these two purposes, NumPy module is available. Okay, na? What are the operations I am going to do? We are going on telling into multiple classes. Now coming to this list. Now you take it, some L3 is equal to, some L3 is equal to, now I am taking, one more I am taking, carefully try to understand, 10 comma 20 comma 30. What is that? 10 comma 20 comma 30, what is it? Can anybody can answer my question? One more I will write it. One more I will write it here. 30, 40 comma 50 comma 60. 60. Next I am writing 70 comma 80 comma 90. What do you understand with this? I just want to know. Inner list. Next list in a list is called what? Inner list. First of all, screen is visible. Huh? Visible? Huh? No problem. Na? Answer my question. What is that now? Inner list. Right. So I am feeling that this is called one row. This is called another row. This is called another row. Okay. How many rows are there? 3 rows are there. Now I want to print L3. Now I want to print L3. Just because understanding NumPy, it takes some time. Try to follow me carefully. So it is going to give you elements are printed something like this. I want to print something like a matrix format. How do you print it? For, you already know that, for V in where? L3, for V in L3. Now I will say Print of what? V. What is coming in V? What is coming in V? The first entry. This is called first entry will come in V. Print that row. Next second entry will come. Next will print. Next third will come. Third entry will come. Just execute this part. It is going to print something like what? Matrix format. Are you able to understand? Well. And one more thing is, another matrix I want. Another matrix I want. Another matrix means another inner list I will design. Are you following? So how many inner lists are there? 2 inner lists will be there. Let me take it. L4 I will take it. L4. I will take it, students. L4. I am taking L4. Understand me carefully. Here I am taking 1 and 2 and 3 and I am taking 4 and 5 and then 6 and then 7 and then 8 and then 9. So this is called one more kind of list. Now I am saying for V in L4, print of V again. Print of V again. Right? Carefully try to follow. Now you see one more type of matrix is printed. Looking like a matrix. Well, looking like a matrix. Now I am interested to add this L1, L3 values and L4. One L3 is called what? One inner list. One more L4 is called another inner list. Now I am trying to add these two. How you are trying to plan? How you are planning to do? L5 is equal to L4, L3 plus what? L2. L2. What will be the answer? 10 plus 1, 21. 10 plus 1, 11. 20 plus 2, 22. 30 plus 3. Like that. Will you get a matrix addition? Or will you get a L2 and L3 elements concatenated together kept in L5? What is your answer? This is what you are not remembering. In the beginning days, if you open the notes, list contains one extend function. Extend function. There I said plus operator. If you open your notebook, everything is recorded. So what is there in that? L2 values, L3 values plus L2 values. L3 na L4? L4 that is. L4. L3 plus L4 are concatenated together, combined together, kept into where? L5. See that print L5, which is nothing but if you execute, this elements plus this elements are combined together, they are coming. Combined together, they are coming. They are not added. If you open your notes, extend function can extend one list into end of the another list. If you want to go for more number of list concatenation, I'll go for a plus operator. So here I am writing for V in L5, print of V, if I take it, it is going to show all the elements here, not at all adding any kind of values. What it indicates? Our Python is quite away from doing the operations called something like this. Then I want to carry out the same type of operations by using what? Some module where it can do some extra calculations for us. Shall I show you that? Let us convert which one? L3 into what? I am converting now. First time I am showing you converting that L3 into what? Our NumPy kind of programming. How I am going to do? A is equal to NP. What is NP? Alias name for what? NumPy. Students in the online, are you following, guys? Are you following what I am talking about it? It's very, very important. So easy for you. Nothing is difficult. Actually, NumPy is dead easy. Yeah. Come on now. Come to the point of it. NP dot, there is a function called array. I'll explain what is that array. I will give a lot of description about it. The name itself says array. Okay. There you say L3. L3 you say. Well, it is converted. You say B is equal to NP dot array of what? L4 you do. L3 is called what? One inner list. L3, one inner list. Next is called L4 is called what? Another inner list. Now I am converting into what? NP into this place. And print of A. Now I am printing one more called print of B, print of capital B, which I took it to the variable like that, and say run. See that it is going to be taken as what? Observe the memory organization also. See, my dear students, when you are displaying the elements of L3, when we are displaying the elements of 1 minute, I will take one pointer for me. One pointer I will take it for my explanation. So I'll take it. Okay, students, come on to this point. Here, for this L3 is concerned, observe this display. Every element is internally separated by comma, 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 comma. So this is called list or internally organizing the elements by separated by comma. To organize this comma also some memory space is taking. But when you come to this place, here, when I converted these things into NumPy, there is no comma, nothing is there. That means even in memory point of view also, NumPy is very much minimal memory space is taking compared to what? Traditional list of Python. Traditional list of Python will take more memory space, whereas this is taking what? Less memory space. And one more thing in the internal part, if I speak, the elements of list, we are seeing that elements of the list are separated by comma and etc. These are not continuous memory locations. These are not continuous memory locations. They are what? Scattered memory locations. The address of 10 is different. The address of 20 different. They are all called what? Non-consecutive memory locations. Available in different memory locations. But when you come to this arrays of NumPy, they are going to be storing the elements into what? Consecutive memory locations. Consecutive means what? Adjacent to each other. And retrieving the data from traditional list, it will take some time internally, and retrieving the data from NumPy will take very much less time. And moreover, minimum memory space will be taken by NumPy, and traditional will take what? More amount of memory space is taking for organizing comma and all those things, different things. And moreover, I'm going to say here, see this now, A and B are the two matrices. This is called one matrix. This is called one more type of matrix. See, my dear students, I'm writing simply C is equal to A plus B. A plus B. What is this? After all, one arithmetic operator I am using to add two matrices. Is it easy to write or the complex to write it? Easy. And print what here? C I am saying. Print of C I am taking. And run this code. What is the answer is coming? 10 plus 1 is called 11. 20 plus 2 is called 22. 30 plus 3 is called 33. Like that I am getting it. What is this operation is called? Matrix addition. What is this operation is called? Matrix addition. One more thing I will show you in other words. In other words, you can see D is equal to NP dot function name called what? Add. What is the function name? Add is a function called with respect to NP. What is NP? Alias name for NumPy. Dot add of A comma B. A comma B. What do you mean by that? In NumPy, lot of things are self-explanatory. Because once if I keep you on the track, whatever I write it, you will understand. Come on, say NP dot add of AB. What is the meaning of it? A and B matrices can be added and kept into the another type of matrix called D. Print of what? D. You say print of D. See the answer. Okay. All the students in the online, are you able to hear my voice? Come on, fast. So you are going to, okay. Now let us move to the further now. See that we stopped here. D is equal to np dot add of a comma b. What is the meaning of it? Print of what? D. When what is this add function here? It is one of the predefined function present in where? What is this add function is called here? Predefined function present into which module? NumPy module, and we are passing AB and keeping that result into A plus B added and kept into D, and we are getting this. So the main importance of this thing is with the NumPy, with the traditional Python programming, there was no operations like what? Adding of list and getting the addition of the list. But such a type of operation can be easily carried by using what kind of operations? NumPy kind of operations, you can do it. So NumPy is going to provide even the complex kind of programming will be providing an easy manner by using lot of functions which are provided to us, right? So let us coming to the next discussion, which I am going to open it, some small description to you. And the next I want to go for differences between. So NumPy is meant for what? NumPy uses are what? Tell me, what are the uses of NumPy? First one is called what? Basically, it is used for what? Arrays concept. Basically, we are using for what concept? Arrays concept. And next I am going to use it for which purpose? Complex mathematical calculations purpose. I will use this NumPy module. These are the two aims of NumPy module which we use it. So these complex modules may be in different occasions you will come across. Still, if you done data science kind of course, you might be used in data science, different algorithms may be there, different calculations will be there. There you will be using this complex calculations. So at this point of time, I'm going to use for organization of arrays as well as what? Complex mathematical calculations. And can we do the both of them as a part of our traditional Python programming? We cannot use it. And moreover, I'm going to give you some clarity on difference between list and NumPy. This is also one regularly asking question in the interview point of view. What exactly the difference? While NumPy and list, especially speaking, there was no comparison between list and NumPy, because we used to consider the list because this is only the one which is going to be a mutable, as well as some homogeneous elements can be allowed. There is no comparison which is going to happen with a tuple and NumPy. There is no comparison with a tuple and what? NumPy. Why? Because a tuple is called what? Immutable. That also organizes in the form of what? Homogeneous. That also organizes in the form of what? Homogeneous. But it is going to be called what? Immutable. There is no comparison with it. And a list is called what? Mutable, as well as NumPy is also called mutable. NumPy is also called mutable. And next I will go for list, you take it. That also organizes homogeneous values and heterogeneous values. But NumPy will organize what? Homogeneous values. I mean, even though you organize the elements in the form of what? Homogeneous plus heterogeneous, internally taken as what? Homogeneous. And that is one of the very regularly asking question in interview point of view. I mean to say, you come to this point, once I will show you. Let us coming to down. L1 is equal to 10 comma, row sum comma. Next is called what some 34.56 comma, something like true comma, 2 plus 3j. These are values. It is called what? List. Print of L1. Try to execute. I'm getting this type of things. What is the type of it? Print type of L of 0. Which type it is? L1 of 0. Next I will take it. Print of, I'm writing here one more thing. Print of, I'm saying type of L1 of 1. L1 of 1, let me write it. L1 of 1. Similarly, L1 of 2. L1 of 2, I will take it. So I'm saying I will print all the types here, try to observe it. It is called 2. Next is called what? 3. How many elements are there for me? 4 elements are there. What is the first type? Come on, try to understand. First of all, do you know it is an indexing? What is an index type? First one, int. Second one is str. Third one is float. Next one is bool. Bool. Next is what? Complex. Complex. So 0, 1, 2, 3, 4. 0, 1, 2, 3. And one more also I will write it. One more also I will write it. It is called 4 I am writing. Then try to execute. Execute. That means our list is organizing everything in the form of what type? All int type, float type, bool type, and what? Complex type. Did you understand? If I convert this into which type? NP array, that is called NumPy programming in the NumPy data structures. Very slowly I am going to convert into that. A is equal to NP dot array of what I am converting? L1. L1. First of all, is it possible to convert or not? NumPy is meant for what? Arrays organization, first of all. Is it possible to convert or not? It is happily possible to convert. It is happily possible to convert. That means this is what people says that are not possible. It is possible. But everything, 10 is what type? Int type. Rosum is what type? str type. All these things are different types are there. But when you come to the NumPy, they are not treated as a different types like int, float, str, bool, and complex. They are all treated as what? Super type of all int, float, complex, str, and bool.
Recording stopped. Recording in progress.
Okay, now start. Students in the online. Okay, students in the online, can you tell me? Am I audible? So what happened today, sir? Okay, nothing has happened. In Hyderabad, there is some winds are coming and some cloudy. That's why this power cut is coming. Some small disturbance in the power. So I hope you will understand. Now we will continue. Okay. So is it now coming to back? NP dot array of L1. What is happening? Even though this L1 is containing, how many values? Multiple values of which type? Different type. We are going to get all of them into which type? Single type. What the single type is? Print of what? A, which is going to print everything in the form of what? Actually, it is going to print everything in the form of some higher type. It is converted. You see carefully in this case, whether you understand or not. 10 is which type? Int type. Row sum is str type, float type, true, and then complex. Who is the common friend of all these things according to our typecasting techniques? Don't move like that. Who is the common friend of all these things? Who is the common typecasting technique which can convert? STR. STR can do it. Now print this now, run this code, see that everything is organizing internally in the form of what? STR. Are you understanding? STR. Now I'm going to print what the type is internally taken. Print of, you don't worry, today I'm printing D type. D type I'm printing stands for data type. D type, which I'm just executing that. What is that now? U64. That is nothing but I will explain. U stands for Unicode. U stands for what? Unicode. Unicode. Unicode is nothing but ASCII. Unicode, like that we are having some representations or not. So this is nothing but U64 is nothing but everything is internally treated in the form of which type? String type. Which type? Now, my interest is I don't want to treat everything as a string type. I want to treat them as a super type of all the types. Who is the super class for all the type? Int, float, and all the classes? Object type. Sir, how to do that, sir? Same thing, my dear students. A is equal to, I mean, why I am telling this example is, even though we have different type of elements are there, when I got it into which type? NumPy kind of a data structure, which I am coming to very slowly. ND array, I will introduce all those things very shortly. So when I am converting into this NumPy programming kind of object, it is everything is treated as a common type called what? STR. but I don't want to treat them as a which type, string type. I want to treat them as it is as elements like that. How do you do that? See that B is equal to NP dot NP dot. I'm explaining here and there some points to understand you the advantages of NumPy directly. So there I'm writing, you say students L1, L1, come on, D type is equal to, I'm writing object. I'm writing object. That means I want to organize elements of L1 as it is, as it is, like this, same to same, but by treating them as what? Not a string type, by treating them as which type? Super type of all the types. Print B, which is going to print B. You just run this. It is going to be treated everything as like that only, but no double quotes, no single quote like that. It is just taken as it is. What is the D type you print, sir? Print of B dot D type, print D type, which is going to print what? You see that what is printed? Which type? Object type. What is object? Superclass or implicit predefined superclass for all the type of values which we have in that. Now you tell me, according to your discussion, these values are same or different? Are the same or different? Same. Which type? Object type. That means NumPy organizes NumPy programming. Even though you have different type of values here, all of them are organized in the form of which type? Same type like str type, same type like str type, and same type something like which type? Object type. Did you understand my discussion? So tell me, what is the difference between traditional list and then NumPy programming? Slowly, in the NumPy programming, even though we represent different type of elements, all of them are treated as which type? Super type of all the types, that is called object. So tell me, in NumPy, can I organize same type of elements or different type of elements? Same type of elements. So if they question you, if I have number type, string type, float type, complex type, will they treat a different type or will they treat one type? One type. What is that one type? Object type. What is that object type? Super type of all types of values. Did you understand? Right. One more small example, one more small difference I want to show you. Look at that. L1 is equal to, I am taking something like, 10, 20, 30. 10, 20, 30. Now I am saying that L1 is equal to L1 plus 1. L1 plus 1. What is your opinion? L1 is called what? List. Now I am taking L1 plus 1. What do you understand from that? Print of what? L1. Print of L1. What do you think about it? L1 plus 1. That means to the iterable object, I am adding the value called 1. I am expecting the value called 10 plus 1, 20 plus 1, and 30 plus 1. That is nothing but I am expecting L1 is supposed to be incrementing the values of this by 1. But will it happen with this? No. See that it is going to give you an error. It is going to give you an error. List to list can be extended, but you cannot do any numerical value. That means you cannot perform any vector operations on list. You cannot perform any vector operations, we can call. Any numerical value adding to the iterable object is called vector operations, which is not possible with what? List. You go to A is equal to NP dot what? Array. NP dot array of what? L1. NP dot array of L1. Convert these elements into which type? Which type? NumPy programming type here. I will talk about, there is a data structure called ND array. So much of things I will explain. Now I am going to take what? A you printed. Just to print A. So it is going to be printed like that. Now I am writing A is equal to what? A plus 1 you say. Now print what again here? A you printed. See what is happening. It will become 11. It will become 21. It will become 31. It will become 31. Now print that, execute that. It is going to become 11, 21 and what? 31. What is this is known as? Vector operations are possible with what? NumPy programming, which is not possible with traditional kind of list. And moreover, finally, list contains how many functions? 11 functions are there. Copy function, insert function, 11 functions are there, which I said everything in the class. Whereas NumPy contains more than so many number of functions are there. Many more functions are there, which we can use in traditional programming, in our normal mathematical calculations. We can use it in ML, mission level programming, deep learn programming, depends on the algorithmic approach. We can use in many more places. And so many, some hundreds of functions are there in which module? NumPy module. Do we have that many rich set of libraries as a part of our list? No. So what are the differences between list and NumPy programming? List organizes both homogeneous and so which is not comes under the mechanism of arrays purely. Whereas NumPy programming provides, even though you organize both homogeneous and heterogeneous elements, internally taken them as which type? Same type. Same type. How do you feel that it is the same type? Just now I shown you. Which type they are taken by default? STR they are taken. Unicode they are taking. I can just mention my programming. D type is equal to what? Object. So that they will be taken into which consideration? Object type. That is called homogeneous only, na? And next, one more thing is what? List does not have any high library to do many more matrices operations. And how can I do this here? With what? NumPy I can do many more operations like this. And moreover, one more thing is what? List cannot perform what operations? Vector based operations. And NumPy can provide what? Vector based operations. And the list elements are what? Heavy memory space is taken and taking more time to retrieve it. But NumPy will take what? Less time and less memory space, less execution time also it will take. I will show you that with a practical example. And don't believe that that is by default it is available. I will show you one counterpoint of it also. Right? I will show you that. Wait for that. In the next session, I will show you that example. Because of purely programming, I will enter into that. Today, I want to give you the differences between traditional list and NumPy. Because everybody will ask this kind of question. What is the similarity between list and NumPy? Both of them are organizing homogeneous plus heterogeneous. Even though you organize homogeneous and heterogeneous in NumPy, they are going to be treated as common type. Moreover, both of them are called what? Immutable or mutable? Mutable. Are you following? And last and final, one more thing I would like to say. Look at students. I will take it this kind of thing. See, my dear students, one small thing I want to take it. L3 and L4, this part I will take it. This part I will take it. This part I am going to get it. These two things I am going to get it. Or otherwise, I will take one small example. And last example, I will go for opening the document. A is equal to np dot, I am writing a range of, I am going to say something like, 10 comma 23 comma 23, let it be a comma 23. Do you know range function? Range function. What is the range function contains? Range of value, range of start comma stop, range of start comma stop comma step. Three syntaxes. We are having one more syntax is called what? A range. That is called array range we can call. Arrange, no. A range. Arrange if you write, you will get an error. np dot a range. A range. That is array range. 10 to 23. How many elements are going to come? 10 to 23 minus 1. 23 minus 1. Print of what? A you say. Print of A you say. Try to print it. So it is going to print how many elements? How many elements are printed? How many elements totally? How many elements, ma? Totally how many elements? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 elements are there. 13 or 12? So len of what? Len of what? A. Len of A. You just try to run this. You are getting 13 elements are there. Let me take it. I will take 22. I will take it. 22. I will take it. I am running once again. I am running once again. I am running once again. You say len of A. How many elements? 12. Now I want to reshape that elements. Suppose this is called what? If I take these elements in the list, that elements will be available as it is like this only. If I take that elements into list, you see here I am taking some L1 is equal to like this I am taking and print what? L1. Print L1. You see, you execute it. This is called what? Okay, of course, comma you need to give. I need to give comma there. And this is a open part. I'm going to show you an important explanation. Try to observe it. Comma, comma. All of them try to give these elements with a comma. Yes, now try to execute. Now I'm getting these elements are done. These elements are also available. Where these are available? A. Where these are available? In L1. How many elements are there here? 12 elements are there. I printed A dot length. Now I am going to say A dot, there is one now, reshaping the array. I will explain this. I am explaining the differences between list and NumPy programming. For this purpose, I am showing code-wise segments here and there. I am explaining. Reshape of 12 can be formulated in how many ways? 12, 4 into 3, 3 into 4, 6 into 2, 2 into 6. So 4 comma 3 I am going to write it. 4 comma 3 I am going to write. Run this code once. See that it is going to say 4 rows and how many columns? 3 columns. Can you reshape the L1 elements like that? First of all, are you following? 12 elements are there with me. I am trying to reshape. Reshape is also one type of function. I'll explain that. Now I am reshaping into what? All these elements which I am having, I am reshaping into a matrix of 4 comma 3. Now I would like to reshape of 3 comma 4. 4 comma 3 and 3 comma 4. I will run once again. It is called 3 comma 4. 3 comma 4. 3 rows and then next. I will reshape once again into what? I will reshape once again into what? 6 comma what? 2. 6 comma 2. You see that 6 comma 2. One more kind of thing, you reshape it as 2 comma 6. 2 comma 6. You try to reshape it. Try to run this. What is happening? 2 rows and 6 columns. Now I will try to reshape it. See this now. I am going to say how I am going to 2 comma 2 comma 2 comma 2 comma. What is the meaning? How many elements? I will say something like 3 comma 2. What is that meaning? Multi-dimensional array I am going to take. The element 12 I am going to divide into two arrays I want. With that 3 rows, 2 columns. Are you following? This I will explain. Multi-dimensional array I am trying to say. 3 into 2, 6. 6 into 2 is called what? 12. You try to run this code once. You see. This is called one array. This is called another array. What is this arrays are called? 2-dimensional arrays we can call. Did you understand what I am talking? So, I don't know whether you are getting me or not. What I am trying to say here. So, it is bouncing to you. Don't worry. I am just saying to you. One more time I am writing. One more time writing. Here I am writing 3. And I am writing here what? 2. How many arrays I want? How many matrices I want? 3 matrices I want. What is the order of it? 2 rows and 2 columns. Run this. See that this is called one array, one matrix, another matrix, another matrix. Is such a facility available with Lista? Is such a facility available with list? No. This is what I want to show. I will explain reshaping concept and all those things. Nothing to worry. This entire discussion shows you what will be the richest functionality of list and what will be the lowest facility of traditional list we are talking about it. Are you able to get me? So let us come back to straightforward. So I have some small documentation with me. I'm going to let me before that students in the online, did you understand what I'm talking, guys? Did you understand what I'm talking? how to install FNs from functions from NumPy. Is it necessary to install functions? Huh? Are we installing functions, guys? Huh? Are we installing functions? What we are installing? Module we are installing. So that we already discussed it. So coming to the, we used to install only module, not functions. Now I am going to show you a small introductory point. I'm going to give you introduction to NumPy. You please look into that. Yes, I'm going to explain that. Ibrahim, I'm going to explain. Don't think that I'm going to explain only one day. I'm going to show you a number of days this NumPy is. Don't think that one day NumPy is over. I'm going to explain some number of days. Look at that. Introduction to NumPy. NumPy stands for Numerical Python. NumPy is one of the predefined third-party module or library. To use NumPy as a part of our Python program, we must install NumPy module explicitly by using what? Tool called pip, which is present into where? I used to tell even in our case of what? cx_oracle time also. And how to install? Cx for installing any module. Pip, install module name. Install NumPy module. How do you install the NumPy module? Pip, install module name is called NumPy. So to use NumPy as a part of our program, we must use which module? NumPy module. A NumPy module is a collection of variables. Next is what? Functions and what? Classes. So already you know a module is a collection of variables, functions and classes. Coming to next, history of Python. History of NumPy. And just now briefly I said, NumPy was developed by studying the existing module called what? Numeric library. Before Python, there is an ABC language. Before NumPy, there was a library called what? Numeric library. This is the origin for development of what? NumPy module. The NumPy library was developed by, the numeric library was developed by Jim Hungunian. Right? I'm writing here, Hungunian. The numeric library was not able to solve complex mathematical calculations. So what came into the picture? NumPy module came into the picture, developed by what? Travis Wolfend in the year 2005. And no need to remember this year and all those things. Just try to remember that. And don't think that a NumPy module developed by Rosum and all those things. It was third party. And a NumPy module developed in which language? C and what? Python languages. And coming to the uses of NumPy. Uses of NumPy. First one is what? An alternative for what? Lists. And what? Arrays in Python. NumPy is an alternative mechanism and highest mechanism for list as well as arrays in Python. And NumPy arrays are stored at one continuous places in the memory. Continuous places in the memory. Unlike what? Lists. Lists are storing the data in where? Heterogeneous locations. Non-consecutive memory locations they are going to store. Retrieving the data from list will take how much time? More time definitely. Whereas NumPy will take what time? Less time, because they are storing into where? Continuous memory locations. So that processing can access and manipulate them very efficiently. I will write it. Processing, comma, accessing the elements and manipulating them very efficiently. Because of what? Continuous memory locations. And NumPy will take what? Minimal memory space. And the next is called what? And the minimal memory space means it is not 100% correct answer. Because I will show in the class what people says minimal memory space. I also will accept it 50% because I will show you 50% contradictory to this point. This I did not show. Even Travis Wolfend only has given that type of explanation. I'll show you that with programmatically. What people are showing some small example and all those things, don't try to believe it. I'll show in the class. Using NumPy, we will go for what? Multi-dimensional arrays also we'll do. Last part is that only I said. What is this part, ma? What is this part is called? One array, another array, another array. How many arrays, how many matrices are there? How many arrays are there? First, 3. What is the Rows and columns, two rows, two rows, two columns, two rows, two columns everywhere else. How many matrices are there? Three. 3 comma 2 comma 2. What is the meaning of it? Three matrices with the order of two rows and then what? Two columns. It is called what type of things it is? Multi-dimensional arrays. Spell out. Sir, how do you print that multi-dimensional arrays? A dot ndim. Ndim stands for what? Dimension. Print of A dot ndim. A dot ndim. See that it is going to be, what is this now? 1 minute, mom. 1 minute. A is equal to, I will just 1 minute, you give me the time. I will show you that. Because I want to keep that reshaping value. Yeah. Print of A. Print of A. Just execute, give me 1 minute time. A dot ndim, ndim, and print of that. Dimension also I am going to print it. You try to execute. What is the dimension? 3. What is that meaning of 3? 3-dimensional arrays. When I take only the array like this, where is that array? Here you see, this one. It is called which dimension? 2-dimension. 2-dimension means rows and columns. Here if you take it beginning, only one level, this is called what? Only 1 dimension it is. 0 dimension is also there. So NumPy is going to build what? 0-dimensional arrays, 1-dimensional arrays, 2-dimensional and what? N-dimensional arrays it can build. Whereas who cannot build that? List cannot build what elements? 1-dimensional, 2-dimensional, 3 and n-dimensionals are not possible. Right? And mathematical operations with a NumPy are so easy. Just now you have seen in the beginning of my class, I want to do addition of two matrices. How we used to do? With the plus operator, with the add function we used to do it. Are they easy or difficult? Easy. When we take a normal list, will they take a lot of time or not? And there is no direct function is available inside of what? Lists. So we are using NumPy for the purpose of what? These many number of things. Now I am going to show you the differences between traditional list and what? NumPy module I want to show you. So instead of writing this entire thing, it will take some time. I will use some maximum time of my explanation, which is already there in my notes. So let us coming to that. Traditional list versus NumPy module. Whatever I gave in the explanation, I am going to show you the same thing. An object of list used to store, first similarities I am talking. An object of list used to store multiple values of same type and what? Different type and both the types. With a unique plus what? Duplicate elements. In which object? This is the same thing I was written in our list properties also. List. Coming to, in NumPy programming, the data is organized in the object of ND array. First time you are coming across one type of element here. What is list? What is list? Totally out of order. What is list? So L1 is equal to list of print of L1, comma, type of L1, type of L1, comma, type of L1. What is list? Class. So that you are not saying. What is list? Class. What is set, tuple and everything? Is a class. Right? So in our Python, how many classes are there for data types? 14 data types are there. In NumPy programming, we are organizing all types of our arrays and complex mathematical calculation in one of the object. That object is having a class whose name is called ND array. What is that array? ND array. Like a list class, ND array is one of the class whose object going to organize arrays elements plus complex mathematical calculations can be done. What is the purpose of NumPy? For arrays organization plus complex mathematical calculations can be done very easily. To store my arrays, to store my complex mathematical calculations result, I need an object. Which object that contains? That object must contain a class or not? What is that class? ND array class. What is that class? stands for n-dimensional array class. Take one example immediately. Take one example which I told you there itself. Say numpy import numpy as np. Numpy as np. A is equal to say take like this of 10, 20, 30, 40. 10, 20, 30, 40. Print of what? L1 comma type of L1. What is that data? This data available in the form of list object. In which type it is? Right. Now I am going to convert this list into what? NumPy programming. Now I am going to organize my list data, traditional Python list, into what? NumPy programming. So I am taking A is equal to, some variable name is equal to np dot. To create an ND array object, there are so many mechanisms are there. First point entering into the programming, I am converting the traditional Python list data into where? NumPy programming environment I am bringing. In the NumPy programming environment, to store my data, I require one object or not? In Python, data is stored in the form of what? Objects. Objects require what? Classes. Which class NumPy will go for taking? ND array. ND array. How many ways are there to create an object of ND array? There are 6 to 7 ways I will tell you. Let us first one. np dot array of L1. L1. Right? Print A comma what? Type of A. A comma type of A. What is A? Object. What is L1? If you don't answer, I will convert into online. Speak. Fundamentals I am speaking and I am entering into the advanced. What is L1? Object. Of which type? List type. Similarly, what is A? Object. Every object require what? Class. Now, which kind of class? You don't know that class. So far, I am coming to NumPy programming. In NumPy programming is a fundamental statement. Remember, I am organizing the data in one object only. That object is which type? ND array class type. Which array? ND array. What is ND array? It is a class whose object organizes our data in NumPy programming in arrays. First one. Number two, on the ND array object, we do the mathematical calculations. See that? I'm going to print. See that now? What is this? Data is available. Which type? What is ND array? Is a class present in which module? NumPy. What is that? Class. Yesterday, lock threading module. ND array class of which module? NumPy. What is ND array class? What is NumPy? A module is a collection of variables, classes, functions. Understand? Now, how many elements are there here? 4 elements are there. 4 elements are available. In where it is available? In the object. Of which type? So it is a gunshot question in interview point of view. What is ND array? Compulsory question. What is ND array? It is a class. In where? NumPy module. Whose object is used for what? Organizing the data. In which programming? NumPy programming. Such a small thing you are reversing. You are getting reversed by yourself. Because basics you forget already. How many ways are there to create a list object? How many ways are there to create a list object? 2 ways. See their answers. 2 ways. What are those 2 ways? L1 is equal to list of. L1 is equal to list of 10, 20, 30. There is a non-empty list, empty list. I already said or not? Like that. ND array object I can create totally in 7 ways. List object can be created in how many ways? 2 ways. Set object can be created in how many ways? 2 ways. Like that I told empty dictionary, non-empty dictionary, empty tuple, non-empty tuple. I said all those things are not like that. In the NumPy programming, where is the data stored? First you tell me that. In the object. In Python, where the data stored? In object. Every object require what? That is okay now. In Python, how many data types are there? 14. All 14 are called classes or not? whose objects created or not. Like that in NumPy also, we are going to organize the data. Where are you organizing the data? In the object. That object require what? Class. What is that class name? ND array. What is ND array? ND array is a class of NumPy module whose object is used for organizing the elements in the form of arrays. On that ND array object, I will do lot of manipulations. For example, which manipulation I want to do it? For example, A, which is I want to manipulate. I want to shape these elements as a 2 by 2 matrix. How I will do? A dot reshape of 2 comma 2, 2 comma 2, 2 by 2 matrix. I got it. Am I doing many more manipulations or not? Many more manipulations I am going to do it. Not only these manipulations, I can do transposing. I can do transpose of the matrix. Many more examples I am going to tell you on this area. So first point you tell me, in NumPy programming, data always organized in the form of what? Which is one of the predefined class in which module? NumPy module. Clear? Anybody ask you tomorrow what is the ND array? What is your answer? Is a class whose object is used for organizing the data in which programming? NumPy programming. Only one object can organize everything in the form of the object. On that object, lot of operations I can do. If I go to pandas, there are 3 ways are there to organize my data. 1-dimensional labeled array, 2-dimensional labeled array, and panel data is available. Series, data frame, and then panel. That is pandas level. When I come to that, I will discuss. First, you be perfect in this. Because there's totally new subject for you, some small tension will be there. Tension is nothing. You forget the fundamentals, that's why tension. Coming to the point next. Both the object of NumPy and the list are what? Mutable. That means changes can takes place. Coming to that, how changes can takes place, sir? See that L1. This is L1 is there or not? What is an index here? What is an index of 10? Can I make it as 100? Keeping question mark. That you forget. So I can say, what is that? L1 of 0 is equal to 100. Print of what? L1. Print of L1. Mutable. At the same address, that too. Like that. I want to update this also. I will print A. This is my this thing. What is the value of this? A of 0, A of 1, A of 2, A of 3. Indexing. Same to same. Print A of what? 0. What is that? 10. Come on, say what is this? A of 0 is equal to what? 23. Print A. Again, you see 23. Mutable or immutable? Immutable. So B is equal to A dot reshape of 2 comma 2. I am saying how simple it is. I can't imagine it. Now tell me, what is this? 23, 2 by 2 matrix. I kept into B. What is B? Object. Of which type? Again forget. See that. They are answering. ND array. They are answering. ND array. Since you are sitting in front of me, not answering means I am getting tension. ND array. How do you check it out? Print B comma type of B. What is that? ND array. What is this now? Come on to this point. See, when we come to one stage, we have to get the things like anything. This is called 23. This is called 20. This is called 30. This is called 40. This is called 40. Right? 0th index, first index. 0th index, first index. What is this entire thing is called? B. Am I correct? Now I want to modify this value 20 as 200. Can you modify? Don't look at me. Say, can you modify or not? How do you do? Online students, come on. B of 0 and what? 1 is equal to what? 200. 0 and 1. 0 and 1 is this one. It is modified to what? 200. How do you do it? B of 0 and what? 1 is equal to is equal to 200. First of all, you print that. First of all, you print 20 came or not? In place of 20, I want to write it what? 200. Print B, modified or not? So ND array is a mutable or immutable? Mutable or immutable? So in NumPy programming, how the data is organizing? See there, they are answering. In NumPy programming, how the data is organizing? In the object of ND array. In NumPy programming, how the data is organizing? In the object of ND array. In Python, how the data is organizing? In the form of int type, float type, bool type, complex type, all 14 types. In NumPy, how the data is organizing? In the form of object of ND array. I am only getting tired by saying the same thing again and again. In traditional Python, how many objects are there to store my data? 14 types. In NumPy programming, how many ways? Only one type. What is that one type of object? ND array object. Gunshot question. ND array is one of the predefined class. Some of the people can say ND array is one of the data structure whose object allows us to store the data of NumPy programming. Which data it can organize? Same type or different type? Same type. They will ask a question. In ND array, I will place different type. Then how you treat that all of them are same type? You have to explain. You have to explain. Number, string, complex, bool, everything is there, but all of them are treated as by default str type. Higher type it is typecasted. If you want to treat them as same type, you can say object is equal to type is equal to what? Object type. You can say what is an object? Object is a superclass for all the classes in Python. For int type, float type, for everything, super type is what? Object. Where I taught that? Inheritance. Okay now? So learning NumPy is looking like learning like a data types in Python. Right? Simple. Easy or difficult? And by looking offline students, I am feeling myself, I am getting difficult by looking at you. Actually, NumPy when it comes, I feel more easy. By looking at offline students, I am feeling more difficult. Whether you will go to home or not, that much tired you are. So I hope easy or difficult? Huh? Or you will come to online? Then speak. All the way coming in summer and sitting in the class. When you don't speak, you tired by summer, you tired by subject. When subject is increasing, should become youth. You become 99 years old after the completion of Python. What is your age? I don't know. Come on to the point. In NumPy, how the data is organizing? In the object of ND array. What is ND array? Is a predefined class. Is the predefined class. In which module? NumPy module. So I am going to enter how many ways are there to create an object of ND array. How many ways are there? 7 ways are there. I will explain 7 ways. After organizing ND array object creation, I will do the operations on it. How I explained list? First list properties, list object creation, list indexing, list slicing. After that predefined functions in list. Like that here also I will go in the same procedure. Because I keep some standard explanation in my classes. Coming to the point of it. Next I will continue. Come on. Object of NumPy and list are mutable or immutable? Right. Come on to next. Differences between Python traditional list and what? NumPy. An object of list contains both homogeneous and values. Whereas an object of ND array of NumPy can store only. Correct or wrong? Correct or wrong? If you look at me, what can I say? Correct. One number, one string, one complex number, one bool and all. When you see that, is the same type or different type? Same type. Which type? Higher type. String type. Later I specified object type. I am telling to PVM, don't treat a higher type. You treat everything is what type? Object type. See in the bracket I mentioned. Even we store different values, internally they are treated as which type? Which type it is? Object type or a higher type in the data. Whatever I am explaining, I just mentioned it. Only thing is I am just taking, instead of typing the same thing, I am just using that. Okay. Next, on the object of list, we can't perform what operations? L1 is equal to 10, 20, 30. L1 is equal to L1 plus 1 is not possible. You got already error. Whereas on the object of ND array, we can perform what? Vector based operations. 10 plus 1, 11. 20 plus 1, 21. 30 plus 1, 31. You got it. That is called what? Vector operations. In the sampling of data, list based applications takes more memory space, whereas ND array object memory space will take less memory space. That is a 50% correct, 50% wrong. You cannot say on the top of everybody list will take more memory space and ND array will take small memory space. I will show you both of them. I will show you, and you that list will take what memory space? More memory space, and ND array will take what? Less memory space. They will fill, but I will show both the ways to you. And when the SAR will show both of them, you will feel, oh, ND array taking less memory space. But when I change that code, changing the code means I will show you that. Before showing why should I take more thing, and keep in mind 50% is positive, 50% is negative. I will tell in the class. Come on to the point. Next, list based applications are not efficient 100%, whereas NumPy based applications are definitely efficient. Example, a list in a list is there, inner list is there. That inner list I want to reshape it. 2 by 2 matrix, 3 by 2 matrix, 2 by 3 matrix, three matrices with 2 rows and 2 columns. Is it possible to reshape? In list, we don't have such functions. Only 11 functions are there. But here some hundreds of functions are there. Who is efficient? Who is efficient? NumPy functions are efficient. So next, list object can't perform which operations? Complex mathematical operations. Whereas, come on, whereas what? Whereas next is called what? Here I am talking about it. ND array object can perform what operations? Can perform what operations? Complex operations can perform. Complex operations can perform. List object can't perform complex mathematical operations because we don't have such functions. Do you have matrix addition function there? Do you have any inner list functions to add? No. Where is that adding things are there? ND array contains what? Adding of those things. Reshaping of elements can be there in where? NumPy. We don't have the reshaping kind of functions in where? List. That's what I'm saying. List object can't perform complex mathematical operations, whereas object of what? ND array. Object of ND array can perform what operations? Complex mathematical operations. How that complex mathematical operations? I am going to show in the class. Up to here, are you okay? What you will learn today? By keeping that practical example, you leave it. First thing you understand, importance of NumPy. History. NumPy stands for who developed NumPy. NumPy uses. NumPy uses two. One is arrays organization, complex mathematical operations purpose. I use what? NumPy. Differences between traditional Python list and then NumPy. I shown you. And one important thing called what? ND array. What is ND array? Class. In where? NumPy or Python? NumPy. How do you know NumPy.ND array? What is the use of that object? To store my data. Which data I can store? Homogeneous data. Homogeneous data, like arrays data I can store. And I can do complex mathematical operations on the data. In tomorrow's class, when I come back, I will explain in how many ways I can create an object of ND array. Okay now? So today what we understand? Importance of it, traditional list and NumPy. And I made you to enter into the first entry in the NumPy programming ND array, a small example I said. Tomorrow when I come back, a detailed explanation I will give you about ND array, whose number of times object creations. Shall we stop the class? Yes. So I'll stop the class. I will tell you this a simple differences I will tell you, and introduction to NumPy I will tell you. Other than that, don't think in the mind. Remember what I am explaining. You have to answer it. How online students are answering quickly. How you are answering? You are seeing me whenever I ask a question. So you can answer. You can also do the same thing even online also, na? By coming in a summer mid 42 centigrade temperature is there. When you are coming means you should answer my questions. Okay, na? So tomorrow onwards, try to answer. Read that first. Okay, I'll stop the class. So tomorrow we will go for what? Explanation about programming. I will enter ND array example, how to create it. Okay, right. Thank you. Amma? Not necessary. You can. I'm practicing here, na? Command prompt. You can practice. You can do it.